All right, let's talk about Cisco ACI. Specifically, we're going to master a really critical skill, verifying the health and stability of your APIC cluster. Now, I know what you're thinking. ACI Fabric discovery is super automated, and it is. But things can and do go wrong, and knowing how to diagnose those issues is what separates the pros. So, let's dive right in.
So here's our game plan for today. First, we'll talk about why this is so darn important. Then we'll unpack how Fabric discovery actually works under the hood. After that, we get our hands dirty with the essential command line tools, see how to use them to troubleshoot real-world problems, and even cover the right way to add or remove APICs from your cluster. And to finish it off, we'll give you a simple checklist you can start using right away.
So why do we need to manually check a system that's supposed to be automated? Well, it's simple. The APIC cluster is the brain of your entire ACI fabric. If those controllers aren't perfectly in sync, the whole management plane is at risk. We're talking tenant configs, security rules, network changes. They could all fail or get dangerously inconsistent. Automation is awesome, for sure, but it's no substitute for actually understanding what's going on.
These right here are the usual suspects we'll be hunting for. You know, things that seem small but can cause huge headaches, like the time being off by just a few seconds. That can completely break Fabric discovery. We're also going to look at what happens when LLDP fails, when you have basic cable problems, or when security certificates expire. By the end of this, you'll know exactly how to spot and fix every single one of these.
Okay, before we can fix anything, right, we have to understand how the system is supposed to work. Fabric discovery is where the magic of ACI happens. It's the process where all the switches and controllers find each other and build themselves into a single, cohesive fabric. It's a really logical process, and once you know the stages, you can pinpoint exactly where things might have gone sideways.
The fabric doesn't just pop online all at once. It builds itself up in a cascade. It all starts with the APIC, finding the one leaf switch it's physically plugged into. We call that the seed leaf. Once that leaf is up, it helps the APIC find all the spine switches. And then, once the spines are online, they act as the central nervous system, allowing the discovery of every other leaf and every other APIC in the cluster. See? It's a nice, logical build-out.
So how does this discovery actually happen at a protocol level? Well, it's kind of like a two-part dance. First, the APIC and the leaf use LLDP, that's the link layer discovery protocol, to just say, hey, I see you. Once they've established that physical link, the APIC puts on its DHCP server hat and assigns the leaf a special IP address. It's called a TEP, or Tunnel Endpoint Address, and that IP is the foundation for all communication inside the fabric. As a switch joins the fabric, you'll see it move through a few different states. If you see unknown, it just means the APIC sees the switch, but you haven't given it an ID yet. Discovering means LLDP worked, but it's still waiting for that TEP address. Now, the one you really need to watch out for is inactive. That's a huge red flag for an IP connectivity problem. Our goal, obviously, is to get every single node into that beautiful active state.
All right, let's get to the good stuff. We're moving from theory to practice. It's time to open up the toolkit. The APIC command line gives us some incredibly powerful diagnostic commands. These are your go-to tools for getting a raw, unfiltered look at your cluster's health. We're going to cover the big ones you'll find yourself using all the time.
If you think there's a problem, this is command number 1. Your first stop, no questions asked. ACI cluster is like a full physical checkup for your fabric. It runs a whole battery of tests automatically. It checks network links, it verifies services are running, it makes sure software versions are consistent. It gives you an amazing high-level summary of your cluster's health in seconds.
And here's what that looks like. You can see it's checking key things like out-of-band connectivity and that internal fabric connectivity using those TEP addresses we talked about. It also makes sure every APIC is running the exact same code version. What you're looking for is a pass next to everything. If you see a fail, that tells you exactly where you need to start digging.
Okay, let's dig a little deeper with something called vectors. Think of a vector as the fabric's master inventory list. Every single device in the fabric has to have an identical copy of this list. FNV read lets you look at the list for all your switches, the fabric node vector. And AV read lets you see the list for your APICs, the appliance vector. These commands are how you make sure everyone agrees on who's in the club.
Now, this is the output from a Cisco AV read. I know, at first glance it looks like a wall of text. But trust me, there is a gold mine of information in here about the health of your APIC cluster itself. This command is how you confirm that every single controller agrees on the fabric's membership and health. Let's break down the most important parts.
Okay, here's your cheat sheet for reading that output. First and foremost, the health score. It absolutely must be 255. Anything less means there's a data replication problem, which is very bad news if an APIC were to fail. Then you've got the fabric name, chassis ID, and cluster version. These have to be exactly identical on every single APIC, no exceptions. And finally, look at the cluster time. If there's a big gap between nodes, you've got a time sync issue. Plain and simple.
So we've learned about the tools. Now let's actually put them to work. In this next part, we're going to walk through some really common problems and use the commands we just talked about to figure out what's going on. This is all about applying that knowledge in a practical, real-world way.
Let's start with the most fundamental question there is. You've got a leaf switch that's not showing up. The first thing you have to ask yourself is, can the APIC even see it at the most basic level? Is that initial LLDP handshake even happening? So how do we check that?
To answer that, you're going to log right into the leaf switch itself and run show LLDP neighbors. You should see the APIC listed there. But here's the key detail, the thing you have to look for. Check the device ID. It should show the APIC's actual hostname. If you see something generic like Vic, that's a telltale sign that there's a hardware configuration issue on the APIC that's messing up discovery.
Okay, another classic problem, especially when a node gets an IP address but still stays inactive, is a certificate issue. All the communication inside the ACI fabric is encrypted and authenticated using security certificates. Think of them like digital passports. If a certificate is invalid or expired, communication just stops cold. The command acudag verify APC is your dedicated tool for checking exactly that.
And the output makes it pretty clear. A failed check often means an expired certificate, yeah? But the real root cause is usually a hardware clock mismatch between the APICs, or maybe even an issue with the TPM chip where those secure keys are stored. This command is the fastest way to know if you're dealing with a certificate problem. All right, let's shift gears a bit. We're going to move from troubleshooting to lifecycle management. Your ACI fabric isn't going to stay the same forever. You'll need to add APICs for more scale or maybe decommission old ones. This process, changing the cluster size, has to be done very carefully and in a very specific order, or you risk destabilizing the entire fabric. You handle all of this from the APIC's graphical interface. You'll go to Fabric, then Inventory, and Fabric Membership. This screen is where you set what's called the administrative cluster size. That's your target. The cluster then works to make its operational size match the target you set here. This is always step one, whether you're growing or shrinking the cluster.
Now this slide is absolutely critical. To expand the cluster, you first increase the size in the GUI, then you power on the new APICs. The process is sequential, from the lowest ID to the highest. To shrink the cluster, you do the exact opposite. You have to decommission the highest ID APIC first, power it off completely, and only then do you go into the GUI and reduce the size. It's a reverse sequential process. You have to get this order right.
And before you even think about changing the cluster size, follow these golden rules. 1. Always do this in a maintenance window. 2. Use the commands we just learned to make sure the existing cluster is fully fit, meaning it has that health score of 255 before you start. 3. Follow that sequential order religiously. 4. Be patient. Data sync can take at least 10 minutes per APIC. And finally, once you decommission an APIC, physically unplug it from the fabric.
Okay, let's wrap this all up into a simple, effective checklist. When trouble strikes, start with ACID cluster for the big picture. Then, drill down with AVE read for the APICs and FNV read for the switches. If a switch isn't being discovered, jump on the leaf and check show LLDP neighbors. And never forget the basics. Check the date on all nodes and run Verify APIC if you suspect a certificate problem. This is your core workflow. We've covered a ton of ground today, from how the fabric discovers itself to the nitty-gritty command line and lifecycle management. But the real power here isn't just about being a firefighter and fixing things when they break. So I'll leave you with this question to think about. Now that you have the tools to validate your cluster's health, how are you going to build these checks into a proactive monitoring strategy so you can catch problems before they ever impact your network? Thanks for watching.